So what you'll notice here, there is something you can do with this one. It doesn't fully solve the problem, but it does make the numbers that you're working with a little bit easier. Is there something I can divide all of these by? Like, is there a greatest common factor, I guess is my question, yeah. Between all three of those. 2. I can take a 2 out. That just makes things a little bit easier, that's all, right? So if I take it out, it's going to leave me with 5c squared minus 11c plus 2. I think that's a little bit easier to deal with than trying to come up with two numbers that multiply to 40 and add to negative 22. I think now we're looking at two numbers that multiply to 10, add to negative 11. You see why common factoring is like, it's like your friend. Okay, it just makes things just a little bit easier for you. I think that's easier to work with than the top one. And then just carry the 2 down the whole way, right? So, we just run through the list. What do we got? Got 1 times 10. That's not, oh, does that work? Whatever do you mean? What if I made them if I make them both negative, then it works. Okay. So, well, what's the next step? Are you just gonna write? Are you just gonna do this? What did I say? Don't ever do this. Don't do that. Not when there's an a value up front. Don't do that. That'd be wrong. Yes.
So this is like the m10, a11, or negative 11, but then what's the m10 negative 1?
10. This guy here.
Yeah. Negative 1 times.
Negative 10. Those work, right? 2 negatives make a positive, and then when you add them, it also gives you negative 11. Right? So, we did the last one with decomposition. Let's do the table this time. Okay? So draw yourself a table. You could be anywhere. Okay, it doesn't have to be as big as mine either. Okay? We always go top left is going to be the first term, bottom right is going to be that term. So 5c squared, 2. And then in the top right, bottom left, we're going to put these two guys here with variables on them. So x and minus 10x. And now I'm just going to try and fill in the sides. So horizontally, sorry, what did I do? I'm mixing x's and c's again. Don't do that. They're all c's. Okay? So then work horizontally. What's common between 5c squared and c? Forget about the negative. Okay, we'll deal with the negatives after, remember? Just a c. What about 10c and 2? Yeah?
I just had a question. For the first bit, you say where the m is 40, but where did you get 40?
10 times 4.
Oh, you just did that?
Yeah. So I did the same thing in the bottom. I just think these numbers are a little bit big, right? Like I don't really want to deal with those if I don't have to. So what I did was, I just took a 2 out, and that left me with a 5 and a 2. So when I multiply the 5 and the 2 together, I get 10. That looks a little bit easier to work with, right? Okay? Any other questions? Good question. Okay. So what did we decide what was common in the bottom? 2. We'll deal with the sign after, okay? Then vertically, what's common in the red vertically? I can take a 5, and I can also take a C. So you see that? And then in the last one, Do I see anything that's really common? So we just make it a 1 then, okay? Now let's just figure out the signs. That's the last step. Yeah, go.
I think that the 1 at the top and then the 2 at the bottom, they're going to be negatives.
Okay, good, yeah. So, again, we're gonna do the same thing here. I'll erase some of these highlighter lines so we can see what's going on here. How do you fill in the middle? Well, in order to get a positive 5c squared, both these have to be positive, right? Everybody see that? There's no way, like, there's no negative there. So, okay, so that's good. Those both have to be positive, so we can check that off. Okay? The next one, the only way to get a minus c here is if the 1's negative. Because c times -1, that's what works. Because we've already determined that the c here on the side has to be positive in order to satisfy this box. Right? You see how this is like a little puzzle, but it's not overly complicated, right? We're just trying to untie the bigger picture here, right? Then we know this has to be positive already, right? Because we determined that from the top box. But I need a negative here. So the only way to get that is if the 2's negative, right? Then, if both of these are negative, that turns this box positive. Okay? Is everybody okay? This works, like, I'm pretty confident this works 100% of the time. It's when you start trying to do the signs at the same time that it starts to get messy. Okay? You can't do the signs at the same time. So then the final step is write your 2 side pieces multiplied together. So this is going to turn into, don't forget the 2 though, 2's got to carry down. 5c minus 1 multiplied by c minus 2. Then you're done. More, again, like all the other ones, the more of these you do, the easier it gets, right? Yeah, Coco.
So do you always put this top on first?
Doesn't matter. Doesn't matter. You could flip these around too. Totally up to you. If you didn't believe me, you could check both of them, right? What should we expect to happen if I wrote it like this? If you remember from Friday when we did the expansion, right? Both of these expansions should give me this back. That's how I know I'm right. That's the opposite process. There's factoring, there's one direction, right? Like when did I write it up here? It was on the other lesson where we drew the arrow. I'll give you a flow chart too. I might give you that now. Okay, is that okay? We'll do a decomposition question. We'll do 2 more. Make sure everybody's good. Okay. Let's do this one, okay? 3x squared plus 13x plus 4. Okay, all pluses, that's nice. There's no negatives mixed in there. So you don't have to worry about the signs, I don't think, for this one, right? Because both of these are plus, right? So, your first question is, can you common factor anything out of there? I don't really see anything common between all 3 of these, right? So you're kind of stuck. Which means you're back to M, A, and N, right? So you're going to need 2 numbers that multiply to 3 times 4, which is 12. And they need to add to 13. So let's go figure out our numbers. Well, we start writing the factors. 1 times 12. Right? Those look like they're going to work right away. That's a nice one. Because if I add them, it gives me 13. When I multiply them, it gives me 12. So, let's use decomposition here and then factoring by grouping. Okay, we'll do it this way, and then we'll do one more table method. Okay, so remember, the numbers on the end kind of carry down, they don't change, right? So they're gonna go down, or not the numbers, the terms, that's important, terms. And then we fill in the middle by breaking up or decomposing the middle term. How do we break 13x down? We use 1x and 12x. Okay? And then you can group. How do you want to group these? What did I say? Does it matter? Hopefully, you guys are all looking at that and thinking, okay, I really want to group the 12 with the 3. It doesn't matter though, and the 1 with the 4. It doesn't matter for the reason I'll show you right now. Okay, if I were to do this question, I'll just break it down the middle. Okay. We'll deal with it in 2 halves. What's common in the first 2? Are there any numbers? Can't take any numbers out of there, but there's a variable, isn't there? Yeah, Lucas? Just x. So let's just take the x out. And what's left after I divide both those by x? 3x plus 1. Right? On the other half, what's common? There's no x over here now, right? But the numbers look okay. What could I divide both those by? What is it, sorry? Yes. Remember, it's the greatest common factor, though. If you keep going, you could divide both of them by 2. Let's do that. Just as an exercise. I'm going to take 2 out. What's left, though? 6x plus 2. Okay, I'm happy you said that because somebody else could do this. You know, could I keep going? Is there more I could take out of there? I could divide both of them by 2 again, couldn't I? So then you'd get 2 times 2. The little dot means multiplication. And then you'd get 3x plus 1. So then these would combine to be 4. Okay, so my point is, without writing all that down, because it's more work than you need to do, right? I could have recognized from the beginning that 4 went into both of them, right? So then without writing all of that, I'll move it down here for a sec. If you take the 4 out of both of these, what's left? 3x plus 1. Then I see both these pieces are shared. So I factor them out. 3x, don't forget your equal signs. I always forget my equal signs. And what's left? I show you guys both the table and the decomposition because you can lose people through here, right? You get to choose. Like, I care about this. For the bigger picture, for your bigger picture, and for the courses you're going to take, this is what matters. It's not the process. It's not how you get there. It's just that you get there. Right? So when you get to 11 and 12, the expectation is that we've done this. They don't spend a lot of time going through the process. The 3M, yes, you go through the process again, but this is what we're after for the 3U. It's the answer. It's how you get there doesn't matter. It's whatever you're comfortable with. That's why I'm showing you both of them. Okay. We'll do one more. Okay. We'll do this, what they deem the tricky one, which does look tricky upon initial glance. Okay, so let me rewrite it down here. X6x cubed. Okay? You've never seen an x cubed before. Would I ask you to factor an x cubed question? You don't know how to do that. You better turn it into something that looks like x squared. This is a fair question to ask you. But if you left it as is, you wouldn't know what to do. So what are you going to do? What's common across all three of these? Yeah, Lucas? Just x. Lucas has got a common factor down. Better catch up to him. We're going to take the x out. And what's left after I remove the x's? 6x squared plus 33x plus 45. All right? Now what? Are you going to take anything else out of there? Be careful before you answer, yes? You can take a 3 out of there too. Okay? All three of those are divisible by 3. So the 3 comes out front of the x as well. So we go 3x. And what's left after I remove the 3? 2x squared plus 11x plus what's left on the end? What's left? 15. Is we okay? That, I think, is a little bit easier. Look, again, just to highlight this, if it would work if you decided to go 6 times 45, whatever that is, and add to 33. It would work. I'm not going to deny it. But trying to come up with the factors for 6 times 45 and add, they're too big. The numbers are too big, right? It's just ugly. So why wouldn't you try and simplify it as far as you can? Because this looks all right. 2 times 15 is going to be multiply to 30 and add to 11. That looks a little bit easier to work with. Right? I don't want to do this one. They're too big. Too many factors. Right? With this one, we can start listing our numbers here. 2 numbers that, well, we could just go 1 times 30. Not going to add to 11. Let's go to the next one. 2 times 15. Not going to work. 3 times 10. Not going to work. I don't think 4 goes into 30, so you get to skip that one. Let's go to 5. 5 times what gives you 30? Bingo. All right, there are your 2 factors. They both add to 11 and multiply to 30. Okay. Remember, you're just going to keep carrying the 3x down. And what you're going to do is tell me what's inside these brackets here. You're going to simplify these brackets. Okay, we'll do that with the box method this time, and then this will be the last one. You guys can do some questions, okay, just before you leave. Yeah, sorry. Here, I'll zoom out. Okay, in the top left, you're going to put 2x squared. Okay, here's your table. Let's start reading horizontally. What's there? What can I take out of the top row? Just an x. In the bottom row, thanks, buddy. You take a break if you want. Okay, in the bottom row, what's common in the bottom row? What can I take out? 6 doesn't go into 15, but cut 6 in half, you get 3. 3 goes into both, right? Let's go vertical now. What's common between 2x squared and 6x? I could take 2. I can divide them both by 2. So let's start there. 2, and then both of them have an x, so let's divide by x. 2x. And then in the second one, I can divide both of them by 5, right? Do I have any negative signs to worry about with this question? No negatives, so this is an easy one. There's your two factors. X plus 3 times 2x plus 5. You're done. I like the table method. A little bit more than the decomposition, actually, to be honest with you. Okay, less steps for sure. The only pitfall with the table method is the negative signs. You gotta be careful around the negative signs, but that's it. Okay? Is everybody okay? You wanna do some more questions?
Like, for a test, would you, like, are you gonna make us do both?
I don't care.
methods, or
No,
just-
doesn't matter. I'm just gonna say factor this. And away you go. You get to pick what you want. I might specify on the test. I'm just gonna say factor, right? But there's probably gonna be some questions that say, like, you're gonna have to recognize that it's grouping. You're gonna have to factor by grouping. You know what I mean? This is just, remember, this is just factoring complex trinomials. Okay, underneath that, I don't care what you do. You could do decomposition. Or table. I don't care. What I do care about, can you recognize complex versus simple versus common factoring versus factoring by grouping? That's what I care about. Okay, and for the test, before your test review, I will give you a sheet where it goes factor these by common factoring, factor these by grouping, factor these like simple trinomials, factor these like it'll be segregated questions. That'll be your review. So you have to recognize on the test, this is a simple trinomial, this is a complex. I'm going to use table or decomposition versus I'm just going to throw the variables in front and be done. That's what I expect you to do different, okay? That's all. And that's just purely gonna come out, that's why we're spending a little bit, we're not doing as many lessons today. Let's give you guys a little bit more time with questions, okay? Okay? We will do a quiz